Okay, so what I kind of want to work on next is actually start setting up some of the core functions on the inventory system itself. So these aren't necessarily functions specific to the player character or any NPCs or anything like that. This is kind of just core functionality for the inventory system as a whole. Now, the reason why I do mention that is because you can always create a child of the inventory system and override some functions to change the functionality a little bit for certain scenarios or for certain things. Now, for the player, particularly in this example, I think that we probably want to make it where the player is only limited to holding so many ammo clips, as an example. Now, if we had something like a container, we might not want that same limitation. So we kind of want to start as if it's as broad as possible, and then we can create children of the class, and we can kind of refine some of the functionality for that specific edge case, as it were. And the idea is to do it as a child instead of in the parent. And the reason why is because if you always do it in the parent, you end up trying to handle a lot of edge cases in a single class, where really if you just create a child and just override a function, you can kind of simplify a lot of the process, as it were. It can also help reduce the amount of nodes that is present on screen at once for a given function. So one of the first functions I'm going to add, add item. Simple and straightforward. Now, if we are going to add an item, we can assume that there is already an item that exists somewhere in the world. If we were to create an item in the world, then the world item would contain the item object, which is actually consists of all the data for the item. So what we can do for the particular function is on the inputs, we can just have that as an item base for the object type. And we can just call that item object just to make sure there's no confusion there. Now, the first thing we want to do is contains, is we probably just want to check, is this item already in the inventory? Because if it is, we probably don't need to add it. So we can go ahead and do that. So we do a quick contains. In terms of the add objects, we do want a return value, and that's just to return whether or not we successfully added the item. Now, in this particular scenario, where we're checking is the item already in the inventory, there can be quite a few ways. There isn't really a right or wrong way in terms of how you would want to handle this particular scenario. For me, I am going to treat it as if it failed to add. For some people, it might make more sense that it succeeded because it's already there. It's up to you which way you want to go. It's just something to be aware as you're setting up your system. That's how you've chosen to handle it. Sometimes it can be a good thing just to add a little description in here. So add an item to the inventory will fail if the item is already present. Again, there might be other reasons why you want to fail. You might fail the add. Again, if I was to create a child of this specific for the player, in the add item, we might also do some additional checks first to see whether or not are we trying to add an ammo. If we are, have they already reached the limit? If they have, then we can obviously return false and do nothing. And then it would kind of get kicked back to whatever it was that was trying to add the item to decide what happens next. So I'm just going to leave that there as a return. So the next thing we want to do is we probably want to check, is the item stackable? Is probably the next thing we want to do. So get item object. So again, this is one of the functions that we set up on the base class here. So hopefully you're probably going to start to see why it is that I went through and set up a lot of these functions first on the items. So in a lot of cases, it's just ways of accessing or setting that specific data, because really these items shouldn't really know much more about the world anyway, because they shouldn't need to. So it's quite nice that we're able to set all that up, because that way we have access to them when we're setting up the actual infantry system itself. So in this case we're checking, is it stackable? So this can kind of change how it is that we then want to handle it next. So if it is not stackable, we can just go ahead and just add it straight to here. And the quantity will always be 1. Now if it is stackable, we want to actually go through and check to see if we have an item in the inventory already that is of the same class. So for this I'm going to go ahead and create a new function, and that's going to be find item of class. Item base. Again, I'm going to do that as a soft reference. And the reason why is because there may be scenarios where you might want to actually check in other places, other functions, and it kind of just helps prevent it from accidentally force loading an entire item unnecessarily. Because in this particular case we don't actually need to load the class to check, because if the class is already loaded, then, well, it's already in the infantry, it's already loaded, but again we can make a bit more sense in a second. So in the find item of class we want to return the actual object. So again, that's going to be the item base, but this time I want to do it as an object reference. And we'll do that as item object. So for this, what we can then do is we get the keys. Like so. I'm going to do a for each loop on those. Then when I get class, and then we'll just convert that to a soft reference. And then we can check if it is equal to the item class that we are passing in. Like so. And then we'll do a quick branch on there. Now, we are doing a for each loop here. And the thing about loops, particularly in functions, if we return, it just stops whatever's left on there. So in this particular instance, we can essentially cut the loop short just by returning, so we don't have to worry about doing a break or anything like that. Now, in terms of this particular function, you kind of have a choice here. You could, if you wanted to, add another return value, which could be like a bool. You can use that to say, was an item found or not. Now, because we are using objects, if we haven't found one, so on the completed, so if we've gone through the entire list and we've not found an item, then it's going to return a null object, which is just something we can check here, just like that. And if we were to add a bool, then we'd just be doing a branch anyway. So in some cases, there's not really much of a point having it, because we can get the data we need from what gets returned here regardless. But yeah, so in terms of this particular function, I'd say it's about done. Let me just move things around a little bit. There we go. That's a little bit more condensed there. Just double check to make sure that's all fine. Yeah, so I can't see any issues there. So we come in, we get the item objects, so that's the keys, loop through them all, we get the class, convert to a soft reference, check with the incoming class, if it's equal, we then return it. Now, the thing about this particular function, it does return the first one it finds. Now for stackable items, this is great because there's only ever going to be one in there anyway, particularly in terms of the system that we're going for. If it's not a stackable type of item though, there could be more. So what we do want to do with this find item of class, we do just want to make sure we make it clear that it's only ever going to return the first item it comes across. So again, go into the description, find and return. Again, find and return the first found item object of the specified class. Now, again, it's super important, particularly with infantry systems, that you are using descriptions and stuff like that. Sometimes the functions can get quite complex. Of course, I'm trying to keep them as simple as possible at this stage. But as things get more complex, it is important to make sure that you are utilising the description and potentially even adding comments where possible as well. There we go. Yeah, so in terms of this particular function now, if I hover over it, it will tell me what it does. Generally, from the name, you can kind of guess, but obviously the specific part there is that it only returns the first found item. Okay, so coming back to the main add item function. So we're checking, is it stackable? If the answer is yes, then we want to get the first item of the class. So what we can do is we can get class, again, we'll convert that to a soft ref, and we will pass that in. Now, if this here returns as false, we can just add the item object because there isn't one in the inventory already, so we don't need to worry about incrementing the integer there, which is what we're using for the amount. If it is, what we can then do, because we are using a map, we would then just find the value based on this. Let's try and make a little bit more room. I'm just going to put that to a local variable actually, so found item. Just to try and help keep things a little bit tidier. Okay, and then we essentially just want to add 1 to that value. So in this case, we would then come back in. Again, we still use the add, this time for the found item. But we'll just pass in the updated amount. Now, in terms of what we have here, we could probably condense this a little bit into its own function. And that's actually what I'm going to do now. So I'm just going to select everything here but the actual found, the local variable. And I'm going to collapse that to a function. So increase item count. No, do item amount. Just try and keep it consistent there. Okay, so because we collapsed that to a function, it did keep both of these found items, but we do actually only need 1. So what I'm going to do is do item, and then we can remove the second one. Just like so. Now, because we have collapse this into a function, we may have a scenario where it gets called somewhere where where the item isn't actually in the inventory. So you kind of have a choice really where you do some checks in here to see whether or not it exists in there or not. Or what I'm going to do is I'm actually going to make this function protected. which means this particular function can't just be called randomly from outside from another class. It can only be called from within the infantry system or a child of it. Now this can be quite useful at controlling some additional variables. So ideally, if something is wanting to add an item to the infantry, they should be using the add item function. They shouldn't be trying to circumvent it using the increase item amount function as an example. So again, using those sort of access specifiers can be super useful to try and limit what can be done with a specific class somewhere else. So what I'm probably going to do actually is, because this is a map, it's going to add it anyway. I'm going to, in the increase item amount, I'm just going to run amount. That's going to start at 0. I'm just going to add a branch here. So if we do actually find the item, we can set the current amount up here, and that's going to be used in the calculation there. What I can then do just down here on a sequence is then call the add here. And the reason why is because it then means we can actually use the same function down here. And up here. Yeah. So we actually end up using the same sort of function. The only thing that's different is the object we actually pass through. So if we find an item, then we use the one we find. If not, then we add the item object that we pass in at the function there. In terms of this, it will always add 1. There may be a time where you might want to be able to add multiple, but for now, I'm just going to rename that to increment item amount. Just so it makes a little bit more sense there. And I'm going to add a description as well. So add the item object to the inventory if item two full stops there. Again, so add item to inventory. If item already exists, increase them about 1. So again, it's just making it easier to understand what's actually going on these functions. So in all of these cases here, certainly for now, you can kind of assume that they will all return true. So I'm just going to run a sequence at the front here. And that just saves me having to stick a return node at the end of all of these. Because we do need to make sure, because there is a return value, when we get to the end of a path, like an execution path, we do need to make sure we are returning a value. The reason why is because if the function is used somewhere, it's expecting the return value to do something. So you do need to make sure that you are honouring that when you're setting up these functions. So I do apologise, my voice I'm going a little bit croaky. Might have to go get myself another drink in a second. Okay, so yeah, so in terms of the add item function, already from that we have 2 other functions there, but I like to think that already these are fairly straightforward, not overly complicated. So a quick rundown again on the add item function there. So we just check, is the item already in the inventory? If it is, then we don't do anything and we just say it's failed. Because we would assume that if we're adding an item to the inventory, it's always going to be an external item. Assuming that it's not, then we come in and we check, is it stackable? If it is, then we attempt to find an item of the same class in the inventory. Assuming we find it, then we increase the amount by 1. If we don't find one, then we just add the item object, which will just set it to 1. Similarly, we do the same thing down here as well if the item is not stackable. Once we've done all that, we then just return true to say, yeah, we've successfully added the item. Because on the end of all these branches, it'll end up adding the item to the inventory. Okay, so I'm just going to put these in a few categories. Inventory. Again, just to try and keep things a little bit more organized. Okay, so the next thing we want to do is probably a remove item function. Now, there's actually 2 types of remove that we want. So we can just get, we can just remove the object. Just like that. Now that itself is kind of like a forced removal of the item in a sense, because it's not actually going to take into account how many objects it's supposed to represent. So it could be that there's actually 10 in the int value. So what we should probably do is actually check first, is the item object in here? Oh. I'm just going to remove that for now, so we'll come back to that in a second. So we'll first check to see is the item in there. If it's not, we can actually do a return value again. And I'm just going to set that to a bool. Like so. So we can assume that if the bool is false, then the remove item has failed, and we've not been able to remove it in this particular case because it's not existed. Now, the next thing we want to do here is I'm just going to promote the actual amount to a local variable. So current item amount. And then I'm going to do a check on this. So is this greater than or equal to 1? Actually, no. What I'm going to do is it equal to 1? Because if it is, we can then just remove an item object. And we can just cut that up there. So if for whatever reason it fails to remove it from the map, that'll set it to false. If it's true, but yeah, generally, obviously that shouldn't fail though, so that should return true. Yeah, true if an item was removed, yeah. So that's kind of like a double failsafe on that, an extra failsafe there on there. Now, if we get to here, this branch, and this value isn't equal to 1, then we can assume that this value is higher. Because, in theory, actually what I'm going to do is actually change that to less than or equal to 1. Because, in theory, there shouldn't be any items in here where the amount is 0 or less. If there is, then something's gone wrong. So in here we can just assume that if it's not less than or equal to 1, then it's higher. So what we can do is just decrement, yeah, the item. So what I'm going to do is just duplicate this particular function here, so the increment item amount. And I'm going to go ahead and modify this a little bit. And this time, instead of adding 1, I'm just going to subtract 1. Right, so again, we can just plug in the item object. And at this particular point, we can just assume that we've been successful at removing the item at this particular point. Now, again, this is just in regards to removing an item using the item object itself. Now, generally, that's probably not the way a lot of items are going to be removed, because having a specific reference to a specific type of object in the inventory is going to be quite unlikely. So really, in a lot of cases, it's more of removing by class, essentially. So we would find an item first and then kind of remove it. So what we can do is create another function. So remove item by class. So this time we would actually find the item of class first, and then we can do the remove item. That's assuming that is valid, so we'll quickly put that in first. Although, to be fair, on some of these we should probably check if this is valid as well. So that way we only actually attempt to remove an item if we've been provided a valid one to try and remove. Okay. So, and again, any remove item function, we probably want to return value to know whether or not it's successfully removed. If, in this case, if we go to try and find an item of class and we've not found one, then we can assume that we don't have one, so then the removal failed. So I'm just going to add some additional categories to these. So inventory add. And then again, just trying to keep these organized. And then we'll put the find item of class in under utility. Why not? So hopefully starting to see how we're kind of building up these functions here to get the functionality that we want. Now, the thing with infantry systems, particularly as they get a little bit more complex, is they're not always that easy to test as we go along. You could, if you wanted to, possibly try and play and then look at some of the values in some of the blueprints. Personally, I don't tend to bother these days. Just kind of get to a point where I can test and then see what happens. Okay, so where are we at? So we've got the add items and remove items, and we can find an item of a given class. Now, in terms of the remove item here, do I want to? I was wondering if it should be protected or not. Probably not now. So I'm just trying to think about how it might get used. It should be fine. In terms of remove item, it should be a problem.